Welcome back everyone, and now our all the thing that we have waited for is over, and now we can learn about the extrinsic semiconductor in a detailed way. So here is something that is a real deal. Now you can dope it in two ways, like what is a semiconductor, like silicon, germanium, or carbon, or something like that. So what you dope with? You can dope it with pentavalent or trivalent. Trivalent means in the last cell there are 3 electrons, pentavalent means in the last cell there are 5 electrons. So there is something interesting that is going to happen. When you add silicon with pentavalent, so you have 9 electrons, correct? Now, if you add silicon with trivalent, you have 7 electrons. Fair enough, right? So silicon's contribution is 4 in both the cases as usual. Now here is the 5 electron thing and here is the 3 electron thing. Now if you consider the same orbit, so this is more electron dense than this one. And as the principle states that in the same period the size decreases with increase of electrons. Like I have made something here to make you understand. If you see the period of sodium and go all the way, like it is aluminum and let's say it is chlorine, so the size shrinks, the overall atom size shrinks. So this is a very basic principle. Now but the electron is there, so this is playing the metallic part and this is playing non-metallic part. Remember, we are not considering the silicon here because in place of the silicon you can take the germanium carbon, of course. So we are not considering this because of a reason. The reason is very clear and obvious. In the both cases the contribution is pretty much the same. So if the contribution is same, we are not taking anything else. So what's the deal here? The deal here is when you add trivalent with semiconductor, it becomes p-type or positive type. When you add pentavalent with semiconductor, it becomes n-type or negative type. So positive type and negative type. So here is the deal. Here is the real deal. So it acts as insulator and it acts as conductor. So the same thing, same silicon can act in two different ways if we dope it differently, first with pentavalent or with trivalent. So here is an interesting thing. Like I have always imagined that I relax all the time and get the full score. Well, I do not relax because teachers not let me. Okay, so if you have to score good, you have to study, of course. So this is something that you can brag about. So it can go on the positive trait, it can go on a negative trait in both the cases. So you can act as conductor p-type or positive type, you can act as insulator as n-type or negative type. So this is something that revolutionized the things, and the real deal of the interesting effects are going to start with right now. Now let's study the p-type first. So what are the p-type? P-type means positive type, and positive type, I told you that we are not dealing with the nucleus actually, so we are not dealing with the protons, we are dealing with the holes, means the absence of the electrons. So what here is the deal? The deal is trivalent with semiconductor, like take silicon for example, so to make the things very much ease. And why I'm taking the silicon I will tell you in a moment. So trivalent with silicon, what it is going to make, it is going to make a positive effect. How is the positive effect is coming? Because in the orbit there are just 3 electron contribution in the trivalent, so the most of the orbit is empty and the nucleus dominates there with its positive charge everywhere flowing. So this is something with the p-type. Or you can consider that when you take any kind of compound which is p-type, So you can always say that the number of holes are greater, very much greater than number of electrons. So it no way means that there are no electrons. We are considering the 3 electrons and 4 electrons here. Even without considering the orbits, there are 7 electrons right at the surface, and there are actually more electrons than that. So there is more number of holes, and that's what we mean here. In the next one, we are going to see the n-type. Let's learn about the n-type. So what are the n-type? The negative type ones, like this one. This guy is negative. This is negative one. So what is negative type? Means the pentavalent added with let's say silicon. This is the favorite example of mine. So when we take it as like that, it is negative type. Means there are the electrons which are pretty much greater than the number of holes. So as we have seen here, similarly here number of electrons are more, so it acts as surely non-metal. So the same thing is acting in both the ways. Like in the first one, it acts as metal. So that's how the name came. At least I think so. That the name semiconductor came that it is acting half conductor and half insulator. So midway between there is the discovery of the semiconductors, and the electronics, it plays a major role in your devices which were this big size become this small. So this revolutionary journey came from the transistors, diodes, and all the devices based upon the technology of semiconductor. So you must learn this thing, okay? Okay, so as we have learned the p-type and n-type, now we are going to learn about the forward bias and reverse bias. Welcome back everyone. Now we are going to learn about the forward bias. So let's understand the word bias first. So what do we think the bias is? Bias means taking the favor of. So what favor we are going to make here? So to ease, I already made the diagram so that you can understand this thing clearly. Now what is this side? This side is the P dominating side, means the holes are in majority, and this is N dominating side, means the number of electrons are in majority. The majority of the electrons, majority of the positive charge or the holes. Don't call it the protons, okay? Of course, no, you know that now. So this is the positive charge. We connect when positive with the positive and negative with the negative, we get forward bias. So this is known as FB, means not Facebook, it means forward bias. So in the forward bias, the positive terminal of the battery is connected to the positive side and the negative terminal of the battery is connected to the negative side. As you can see, I have also made the electrons here, but the dominance here I tried to show is the protons. So the protons is a blue color, of course, and here the electron is dominating, means the electrons here, the red side. Now what is this region? So to understand this region, we need to learn something a little more in that. What is known something known as junction? I think you all have heard this if you have ever traveled from the railway station, train, and all that such things. So the junction is a point where two things meet. Like there's a junction in the railways, so it means it is city 1 and it is city 2, and this is the line which is connecting these both two places. So this is known as junction. Similarly, in our case, this point is known as junction. So when we are adding P with N, this is known as PN junction. So what we are studying here is PN junction. So in the PN junction, we considered the battery, and now we are calling it as forward bias. So there's something as reverse bias. Yes, of course, that we are going to study in the next one. And what about this one? As we are pondering, so I let you ponder upon something till the time. So just ponder that why it happens, and think, my dear bacha, think that why the electrons are here and the positive charge is here. Why it is happening. As you can see, this is the positive dominating, means blue dominating area, and in the closest of it is the layer of the electrons that I have made, and this is the negative dominating area, but I have made the positive charge or the holes in this. So think on that one. Now as you can see, we are going to study about the reverse bias. So what is the reverse bias? Similar figure like p-type and n-type as we have seen here. Well, this is seemingly a little bit messy. So p-type means the holes are dominating, n-type means the electrons are dominating. So electrons are dominating and holes are dominating here. So now what we have changed here is just the battery's connection. The negative charge is connected to the positive side or the whole side, and the positive charge is connected, or positive terminal is connected to the negative side or the electron side. So this is what is known as the reverse bias. So in the reverse bias, this region expands actually, and that we are going to discuss in the next one. But for this one, this is all about the reverse bias that you need to know. So in the first one that we have seen, it is supporting. Just remember two words, and then we are going to compare all these things, all the both the things in the next one. So it supports, and what here we are using the word is this oppose. So what it oppose and support? It oppose and support the flow. What the flow can be? It can be the current or the electron. They are technically the same because they both flow in the same wire. One is traveling in one direction, so the other is producing, like the current is producing in the opposite direction of the electron. So if the electron is flowing like this, the current is coming like this. So these are technically very much the same, pretty much the same. So we are going to compare that in next one. Take care, God bless.